yeah, feel free to ask me any questions. So, um, all right. So let me remove this and let's talk about functions and let's talk about arrays and pointers. And again, put all of that together. So first of all, let me create an array, and let me create a function that takes an array. And yeah, let's talk about that. So here I'm going to create a function. Let's say void populate array. So populate means kind of putting values in. That's typically what populate means. So when we say we want to populate an array, that means we want to put values in the array. And here I'm going to create an array, say, for example, int my array. And I'm going to use the old notation like this. And what I'd like to do is I'd like to call this function. So I'd like to say populate array. And I'd like to send my array to the function. And I'd like my function populate array to change the values of my array. So here, I do need to define a parameter. What do you think of this? How do you think that's going to look like? Any guesses? I mean, is it going to be int my array like that? Or is it going to be, how is it going to be? Do you have any suggestions or guesses? I'm going to be sending an array. So Kate is saying this is actually a very good guess, which is that. So, you know, I'm going to be sending an array. Okay. Is there, it's not a bad guess. Is there another, and as you can see here, it's not liking it. Do you have another, you can tweak it and it'll work. Let me tell you, it's okay. You don't, it looks like this. This is actually a better, this is kind of a, it's a better guess, but your guess was not bad, Katie. It was kind of close enough. So you can do that. Is there another way that you think we can do it? What is an array? Do you remember? An array is also something else. So this array is also a list, not quite a pointer. That's good. So Drew is saying a pointer. That's right. An array is a pointer. Because of that, we can actually do this. So we can define a pointer here, or we can define something that looks like this, which is actually an array or a pointer. And what we would do here is we can say my ARR 0 equals to 50, my ARR 1 equals to 90, my ARR 2 is equal to 20. Now, my question to you is, if I were to print the first value of my array is %d because it's an array of integers, \n, comma, my array is 0, what do you think that's going to be? Think about that for a minute. So I'm defining an array here. I'm calling a function, and I'm sending my array there. Of course, it's another name. Doesn't have to be another name, but just to kind of prevent confusion, I used another name here. And then I essentially populated this array with values. Now, what's going to happen if I print the first value of this array? What would that be? What do you think? 50? Okay, that's a guess. Are there other guesses, or do we all feel that it's going to be 50? Okay, it seems that there's consensus here. It seems that we all agree that it should be 50, and that is actually correct. So let me hit play. It'll be correct. That'll be 50. So just to kind of make sure that we understand what I'm trying to convey here, if I have a function that says add 5 that takes a num, and if I say num equals to 200, and if I have, say, int local num, let's call it, say, my num equals to 30, and if I call the function add 5 my num, and then if I print if the value of my num is %d \n comma my num, if I were to execute those 3 lines, it's going to print 30. So changing num here is not going to change my num here. I can show you here. I'm going to return 0. You will see that it'll print 30. You can see it printed 30. So changing num did not change my num here. However, when I created an array here, and when I sent my array here to this one, to my R, and then I changed my R here, and then when I print my array, you will see that my array has changed. So this is different behavior. These two, this one has a different behavior than this one. So here I'm going to add a comment. Calling add 5 will not change my num. However, here calling populate array will change my array. And the reason why this is the case is because my array is a pointer, going to kind of what we started talking about yesterday. My array is a pointer. When you actually send my array, you're actually sending a pointer to the array. So let me show you exactly what's happening here. I'm going to comment this just to simplify things. So when we do the following, we're going to, how about I do something that I don't typically do, but let me try it. Yeah, I don't know if I like this. I don't like it. Okay. Yeah, I think I prefer to do this. Okay. So when we did this int my array 4, we essentially allocated that space, and this one essentially the first element, and this one is the third element, and this one of course is the second element, and this is of course the fourth element. And of course, there's a pointer. We don't want to forget that. And that pointer is called my array. So this is my array pointer, my array pointer, which contains the value 8. That's what's happening. Now, when you call this function populate array and you're sending my array, you're actually sending the value of the pointer to another pointer. So there is this pointer which is called my R. Let's say let's call it my second array because it's hard to pronounce my R. Let's call it my second array. So there's another kind of array which is really a pointer called my second array. And when you're calling that method and when you're calling that function, I should say function, not method. And when you're passing this pointer, you're essentially copying the value of the pointer to another pointer. So my second array is, again, an array and also a pointer. So that would be here. now contains the value 8. So that's what happens. Now, when you go here and you do the following, you're essentially doing exactly this. And let me actually do this. So you're dereferencing that address and you're putting 50 in it. So when you dereference 8, you're going to get kind of here. You're talking about those 4 bytes. And right now you're saying put 50 in those 4 bytes. I'm going to just say same thing as this. Okay? And when you're doing this, you're essentially doing same thing as dereference my second array plus 1. Now again, this is pointer arithmetic. So when you add 8 to 1, you're actually adding 4. You're adding 4 and you're ending up with 12. So you're actually ending up here at the second element. And when you dereference it, you're talking about those 4 bytes. And now you're saying, I want those 4 bytes to be equal to 90. So notice what's happening here. Because this pointer contains the address of my array, this pointer is able to change the array right away because it has the address of the array. And then here, of course, it's going to be same thing as doing dereference my second array plus 2 equals to 20. So if I go here and I say first, first, and then I'm going to say second, and then I'm going to say third. And of course, I'm going to change those to 1, or rather 0, 1, 2. You will see that it's going to be 50, 90, 20. And again, if I change this one to a pointer, it's exactly the same thing. My second array, exactly the same thing. So you can actually use this square bracket notation in a pointer because pointer array, they're kind of the same thing, right? Of course, when you define a pointer, it's different than when you define an array. You know, these two things are different. But when you create an array, it's also a pointer. So in addition to kind of allocating the space, it's also a pointer. So yeah, let me pause here for a few seconds, see if anyone has any questions. So when you have a function that takes a list or an array like this, either like this, or if you want to, like a pointer, same thing, you don't need to return that array. There is no need to return the array. The reason why there's no need is because when you have a parameter that is a pointer or an array, you can simply use that value that's being passed to change the array right away, because this is really the address. And when you say this, you're saying, change the 4 bytes that live starting at the first address. And this one's going to say change the 4 bytes that are after the first 4 bytes. And that would be change the 4 bytes that are after that. So you're changing the array right away, and there's no need, to return anything. After you call this function, the values of the elements in the array have changed. Okay. So we have 10 minutes. I'm going to talk about one last topic, and we might finish a few minutes early, possibly. But there's another topic that I want to talk about that is related to something that we covered yesterday. In fact, it's related to something that we covered at the beginning of today's class, and it's size of. So, do you remember? And I hope you do remember. What would be the output of saying the size of my array %, unsigned long \d, comma, size of my array? What is that going to print in this case? Yeah, so Grace is saying number of bytes, which is 16. That's correct. So that's what's going to be printed. You can see here it printed the size of my array is 16. I should have said \n, not \d. And you can see here that it says the size of my array is 16. Now, here's something interesting. If I call this function populate array, and if I'm sending my array to here, again, this could be a pointer, and it could be like an array definition. And if I say print if the size of my second array is %, unsigned long \n, comma, size of my second, what do you think that's going to give me? Any guesses? 12. Why 12? So Katie's saying 12. I don't know where the 12 came from. Drew is saying 16. Grace is saying 16. 16 is a good guess. So I'm asked to repeat the question. The question is, what is the size, if I print the size of this one, the size of my second array, what would that print? How many bytes? Now we know that when I printed the size of my array here, it printed 16 bytes because we have 4 ints, each int is 4, that would be 16 bytes. But let's say I'm calling this function populate array and I'm sending my array here. And now I'm going to print the size of my second array. And what would that be? So it seems that, some of you it seems that most of you are saying 16. And 16 is not a bad guess. It's not a correct guess. And that's because, so Kate is saying 8. Okay, why is it 8?
Because it's a pointer.
Because it's a pointer. That's good. That's exactly right. So what happens here is when you call this function and you send the array, you're sending the pointer. In fact, if you were to get the size of my array here, if you ask me, I will tell you the number that makes the most sense is actually 8, because my array is a pointer. Now, the reason why we print 16, which is really the number of bytes, is because the C compiler, is kind of guessing that we don't need the size of the pointer and we need the size of the array. So it's kind of helping us out. It's saying, okay, my array is a pointer, I know that, but it's also an array. And most likely, if you want to get the size of it, I'm going to guess that it's going to be 16. It's going to be, the number of bytes. You most likely don't want the size of a pointer. And because you're asking me about the size of my array in the same scope, I can see that there's 4 here. So what I'm saying here is not very accurate, of course. But that's okay. We don't need to know the details for now. What I'm saying is correct. It's just not kind of accurate. I'm omitting a lot of the details here. But essentially what's happening is the C compiler is saying, oh, this is an array, even though it's a pointer, it's also an array. And most likely you want the number of bytes in the array. Because of that, I'm going to give you 16. But if you ask me, I would say it would have been better if the C compiler would have given us 8, because that would be kind of less confusing. That would be more, accurate, more accurate representation of the truth. Because my array is a pointer and the size of a pointer is 8. But again, the C compiler is adding this convenience where if you ask about the size of a pointer that happens to be an array, it's going to give us the number of bytes. Now, when you call a function, yeah, exactly. Let's go back to the question. When you call a function and you send, the pointer, you lose this convenience. The compiler C does not have access to this anymore. It cannot see 4. So what it's going to do is it's going to simply give you the size of a pointer, which would be 8. So let me hit play here. And you can see here that it says the size of my second array is 8 bytes. So this one is going to print 8. However, this one is going to print 16. And the reason why this one is 16 is because, again, C is adding this kind of convenience that's gonna, it's guessing that what we're looking for is really the size of the array, not so much the size of the pointer. This is just something to keep in mind. So essentially, just to summarize, if you're asking about the size of an array in the same scope where it was defined, so my array is defined here, and in the same scope, I'm asking about the size of that array, the C compiler is gonna figure out, what the size of the array is, and it'll tell you it's 16. In this case, it's 16 because it's 4 elements, each element is 4 bytes, that's 16. However, if you call a function and you send an array, and this array, of course, is going to be stored in a parameter like that. If you ask about the size of that parameter, it's not going to know. Why? Because my array, which has the size 4, is not defined here. It's like the C compiler doesn't have access. When the C compiler is here, it doesn't have access to the space. So now, just the last thing that I would say, what if you want to create a loop that populates the array? What if you want to say 4 and you want to say, let's do int control variable and then say control variable is equal to 0. I say control variable is less than something. I'm not going to tell you what that thing is yet. And then I'm going to say control variable equals to, let's say, plus plus. And here I'm going to say my second array control variable is equal to, let's say, 10. So let us assume that I want to populate all the elements with the value 10. So instead of kind of doing this, I want to populate all the values with the value 10. Now, how would I know what this should be? Now, of course, we know that in this case, it should be 4. In this case, because my array has the size 4. So I want to go 0, 1, 2, 3. So I want to go from 0. And that's really what I want to have here, 0. And then I want to increment so that it's 1. So I want to have 1 here, then it becomes 2, then it becomes 3. And that's really what I want. But how would I determine 4? Because of course, maybe I want to call the function again, but using another array, say my other array, which is going to be, maybe 17. And I would say populate array, my other array. So when I call the function here, I'd like this loop to go 4 times from 0 to 3. And when I call my function here, I'd like my loop to go 17 times from 0 to 16. So my question to you is, how can I, do that if I cannot get the size of my array, my second array, which is being passed? So how can I determine this value here, the correct value that's going to make me loop the correct number of iterations? Any guesses? Do you give up? Let's say dereference the array. No, dereferencing the array is not going to work. Dereferencing the array is going to give you the value of the first element. That's not going to give you the size. Grace is saying it's the division we did before. No, you can't. You can't do the division, because if you get the size, let me see, I'm looking at some answers here. Wow, Grace, I think you probably need to rewrite your answer. That does look. Okay, can you try to write your answer so that I can copy it, paste it, and explain, why it's right or why it's wrong? All right. Okay, let me copy it and paste it, and then we can talk about it. So this is what one student is suggesting. But what is the size of my second array? Did you already forget? What is the size of my second array? Can someone tell me? It's going to be the pointer, exactly. It's going to be 8. So that's going to be 8. So this is not telling us the size of bytes. So if you take 8 and you divide it by, let's say we get this right, which is 4, that's going to give you 2, which is not right. So what you're proposing, Grace, is not correct. The reason why it's not correct is because when you get the size of my second array, C is not going to be able to know, because my array 4 in this case and my other array 17 has been defined in this scope. So as soon as you go to another function, this becomes just a boring pointer. My second array is just a pointer. It's just 8 bytes. We don't know anything other than the fact that it's a pointer that points to an int. Okay, so another suggestion. I like those suggestions, not because they're right, but because they make us kind of think a little bit. All right, so size of this. What is this? Can someone tell me what this will do, dereferencing my second array? What is dereferencing my second array? Just the first element. Exactly. That's going to be the first element. So that's like doing this. It's kind of like doing this. So that would be probably 4. And that's not taking us anywhere. So actually, if you think about it for just a few minutes, you will realize that it's impossible, not important. It's impossible to know the size because the size is not being sent. I mean, I'm not sending the size here. So again, when I'm calling my function and I'm sending the array, what's being sent is a pointer. It's a value of an address, and this is a pointer. This does not tell us the size of the array. It's just impossible. There's no way that we can get the size of the array from this. It's just impossible. Like imagine I'm giving you 8 and I'm telling you from the 8 determine that we have 4 elements. Well, you don't know because it could be 1 element, it could be 2, it could be 3, 4, it could be 5. I mean, you don't know if these 4 bytes are the 5th element. You don't know if those 4 bytes are the 6th element. We don't know that. I mean, how would you know that? Because of that, what Drew said earlier is the correct answer. If you want to loop through the array, you actually have to send the size as a second parameter. So it's usually called like array size. So when you call the function, you would say my array 4. Or of course, my array, you can do size of my array divided by size of the first element of my array. You can do that here. That's allowed. Because when you say size of my array, it'll actually give you the number of bytes, which is 12. And then you divide that by 4. And that's going to give, excuse me, here 16. I said 12. I should have said 16. The size of my array is going to be 16. You divide it by 4, and that's going to give you 4. And same thing here. You can say size of my other array divided by size of my other array for the first element. Does that make sense, guys? So if you want to loop through the array, you have to have the size, which is really the number of elements. And because this pointer does not tell you anything about the number of elements, the only way to do it would be to send the number of elements as a second, a parameter. So here you can say array size. And of course, array size could be, if you want to be more descriptive, you can say array number of elements, because size, again, size can mean multiple things. What do you think of this? Give me thumbs up, thumbs down. Does that make sense? Again, in summary, this pointer does not really give us information about the size of the array, because as soon as you send the array to another function, you lose that convenience that C has been giving us, although that probably confused us. That's why I think maybe the size of my array should have been just the size of the pointer. At least we would be less confused about what we're doing here, but that's okay. Right now, hopefully it makes perfect sense. And yeah, that's what it is. So I think this is great. We were able to finish C. This is really the end of C. We talked about variables, if statements, loops. We talked about pointers. We talked about arrays. We talked about functions. We talked about passing variables or lists. rather arrays to functions. We talked about printing and the formatted print. Yeah, so we talked about all of that good stuff. We talked about dereferencing. Yeah, so this is the end of it. That's going to be the last video about C. And tomorrow we're going to probably finish one's complement and two's complement. And then we're going to start with MIPS after that. So before we end the recording, do you have any questions? All right. All right, that's great. Thanks for being here. Again, I hope to continue to see you tomorrow and until the rest of this semester. Let me stop recording here.